This chart maps a 97% collapse in AI token prices. Processing power is now a cheap commodity. But this didn't simplify software development. It triggered the Jevons Paradox, where increasing the efficiency of a resource leads to an increase in its total consumption. This explosion in consumption leads to token waste. Token waste happens when AI agents ingest massive datasets to generate code, but fail to retain the underlying architectural context once the immediate prompt is fulfilled. Generating millions of lines of code without maintaining a persistent state across tasks creates high-velocity noise. The machine completes the request, but the underlying logic is lost the moment the session ends. This visualization shows the activity of a standard coding agent operating today. It ingests millions of tokens, scrambling to execute a single isolated command. The second that isolated task finishes, the agent's architectural memory is wiped clean. When you assign the next task, the agent starts from zero. It must reread and reprocess the exact same context it just discarded. An AI possesses massive computational power, but it lacks the strict engineering discipline and persistent memory required for professional development. Relying on a system that constantly forgets means you are continuously renting transient compute. You pay for the processing, but you keep nothing permanent. To fix this, developers built the Superpowers project. Superpowers functions as the physical, disciplined hands of an AI agent, enforcing strict boundaries on its workflow. The moment you give it a prompt, Superpowers forces the AI to stop. Instead of immediately writing code, it uses Socratic brainstorming, asking you direct, clarifying questions until it extracts a specific design document. This flowchart illustrates the test-driven development, or TDD, protocol it follows next. TDD is a software practice where a developer must write a failing test for a new feature before writing the actual code to make that test pass. Any code written before a test is verified gets deleted. To maintain speed, the system dispatches parallel subagents to independently review the required tasks. These agents operate safely inside Git worktrees. A Git worktree is a version control feature that lets multiple branches of a single repository be checked out in isolated folders at the same time. By forcing a machine to adhere to these standards, the chaos of raw text generation is organized into a repeatable, methodical routine. A disciplined workflow prevents errors in the moment. However, if the agent still forgets everything between sessions, the process remains temporary. That gap is filled by the FastMemory project. FastMemory acts as the persistent cognitive brain for the agent. This network diagram shows the core mechanism behind FastMemory, a structured cognitive layer known as the CBFDAE ontology. An ontology is a formal framework used to categorize data and define the specific relationships between concepts. This specific structure allows the AI to file away institutional knowledge and retrieve it across entirely separate tasks. The agent retains the architectural why behind a development plan rather than blindly executing the immediate how. An AI that recalls past decisions compounds its accuracy over time. It recognizes previous architectural choices, which prevents the need to re-explain the system's core logic with every new feature. This diagram demonstrates what happens when you combine these two systems, the rigid workflows of discipline physically overlapping with the persistent nodes of recall. The merger of these frameworks created a system called Superfast. The integration is direct. Superfast triggers these verification and memory skills within Claude Code or Cursor as soon as the agent detects a new development task. Standard AI agents scale by consuming more tokens, but they remain capped by their lack of memory. Without a way to retain context, more compute simply generates more noise. By pairing elite workflows with fast memory, developers secure long-term digital assets instead of simply renting server time. You can find the installation guide on the Superfast GitHub repository and consider sponsoring Prime Radiant to support their continued open source work.